So this function, you can see when the graphing linear line, x can get from negative infinity to positive infinity, and the y also from negative infinity to positive infinity. When I do the graphing to the quadratics, they have the minimum value or maximum value. X you can change, x you can pick from the negative infinity to positive infinity. That's for the domain. That's for the domain, right? But for the y, since they have a minimum value, right? They have a minimum value for the y. Minimum right here, for this case, is minimum value is, we can read from the vertex. Vertex is 0, -3, right? So minimum value -3. So y is -3, minimum value is -3. And the maximum value, you can see when they extend it here also goes to the positive infinity. So the range for, actually for the y is range. So here we needed to say including from the minimum -3 to positive infinity. So that's why we try to learn from the, what's the domain, what's the range. For the linear line is here, the range, I mean the domain, this is the range. For the quadratic formula, the domain of the x is negative infinity to positive infinity. The range will be different, right? So will be if their mouth is open up, this one is minimum value, the vertex is minimum value, so it's -3 to positive infinity. So if this quadratic is graphing is a mouth like bottom down, it's face mouth down, so have the maximum value to negative infinity, right? And negative infinity to this value. So it should be saying negative infinity to this particular value, per vertex value. So depends on the mouth open up or mouth open down, you need to find out the different range, okay? The range will be a little bit different here. All right. So let's see next one. So this is what we talked about last week. And I will send this one to you guys as the homework. So we see this one. Let's see, go over here, homework part to see what's going on here. All right, so see this one. Let's see this together. So for this one is linear line, right? For linear line, so linear line actually, when you graphing it, you can see that one. Let me graphing here. Take your homework out, all right? So for the linear line, when you graphing number 5, so you can see y-intercept is 0, 4, right? X is negative 2/3, negative 2/3, right? Negative 2/3, 0. Yep, so it will be right like this when graphing. So you can see domain is negative infinity to positive infinity, right? Because they can pick any numbers from here to here. What about y value? Y value also from negative infinity to positive infinity, right? So the range will be negative infinity to positive infinity, right? Because when you do graphing this linear line, you can see x you can pick from here, and y value from negative infinity to positive infinity, right? So for the 5. So for the 6 is the same. They are linear line. For the 7 is the same. They are all linear line. Linear line always show like this, right? But let's some special, something like say y equal 1. This is also linear. Y equal 1, right? Y equal 1. What about domain? The domain is x range, could be negative infinity to positive infinity. What about y? Y only one value, only one value, only 1, right? The y is not negative infinity to positive infinity. In this case, is y only equal 1. The range is y only equal 1. Okay. All right. So 5, 6, 7, their answer is the same. Domain is negative infinity to positive infinity. Range is negative infinity to positive infinity. Anyone got it?
Yes.
Thank you, Mason. How about you, Enoch? I thought you joined a little bit late. Did your answer is the same as what I show here? No answers? Oh no. So for the like this special, like y equal 1, this linear line is different. The same for the the similar thing for the x, say x equal 1. I mean, let's say 2. X equal 2. Let me use different colors. X equal 2. So when you're graphing x equal 2, like here, right? So it's 2, 0. So linear line like this. So this is x equal 2. So what's the range? What's the domain? The domain is only x can only equal 2, right? The domain. Sorry, spell. So x can only have one data, right? What about the range? I say x equal 2. The domain is only one choice, right? They cannot pick negative infinity, any different other numbers other than 2, right? But what about range? Range is negative infinity to positive infinity. Okay, but in this case, x equals 2 is not a function, all right? It's not a function. This one is not a function because when they have one data, the output has multi-data. What a y equal 1. This is function. The one data, one y generated, one x generated one y, right? Each of the x only one y. When you pick any data, you generated one y. Okay. Anyone have a question about this part? Maybe we talk too quick. Let me clear one. Okay, great. Okay, let's see. Let's continue check about 8. Let me go back a little bit. Save these pictures. Make sure you guys will be okay. So let's see number 8. Number 8. So we learned graphing. All right, we learned graphing already. See number 8. So how we graphing this one? Number 8. When we're graphing this one, sorry. So graphing this one actually is, firstly, we're graphing y equal x, absolute x first, all right? Let's see this one. So this one, when we're graphing this one is, you know, this is, we need a graphing like y equal x is this, right? So it's 1, 1, 1, 1, you know. So after absolute is, so this part, actually the right part will be changed. This is the part below the, I'm sorry, oh my gosh, what do I do? What I'm doing. So the part under here, this part will be changed here, right? So actually the graphing is this part is y equal absolute x. They do not like this. We don't need this one, right? You switch back. So y equal absolute x minus 4. Minus 4 means this part moves down 4 unit. All this part move down 4 unit. Move 4 down unit. Here is negative 0, negative 4. So means this one move down here. So will be changed into what? Change into like this. Here is 4, 0, right? You can put a 4 here. If you put a 4 here, here is 4, 0. What x-intercept is? Here is negative 4, 0, right? Here is 0, negative 4. So actually the graphing will be changed into like this. Just like right now we move the green, we like to move the green part down 4 unit, right? So like, when we're graphing here equals absolute x minus 4, right? It's this one. Is it correct? So we can take this green part away, right? So here we don't need this one, don't need this one. So this is the graphing about number 8. Absolute x minus 4 is like this. Okay. Okay, so what's the, let's find out what's the domain. What's the domain? What's the domain? Domain means what possibly x area, right? So what possibly x area? X, so domain will be negative infinity to positive infinity, right? Because of x can be possibly from negative infinity to positive infinity. What about the range? The range will be y value, right?
-4 to positive infinity.
Yeah, -4. Actually, including -4, we use the bracket. We cannot use the parentheses, right? With the, and y gonna be goes to from here is -4, right? Y can be positive infinity. So yes, right? Right. So the range would be similar like the parabola, quadratic graphing. They have the minimum value. Y have the minimum value, right? All right. Any question to this one? Come on, come on.
None for me.
Yeah, thank you. What about others people?
Nope.
Yan, do you have a question about this part?
Nope.
Angela, Zhang. Angela Wang.
No.
Okay, good. Ryan.
No.
Ryan. All right. What about you, Angela Zheng? Okay. No, I didn't hear answer yet. Enoch. Michelle, do you have a question to this part?
No.
Good. What about you, Bradley, did you there? Are you there? Oh no, everyone just hide behind the screen, didn't answer, huh? What about you, Ben, are you there? No, not there. Okay, all right. Ben, I can, I thought you should jump in, but you didn't show up, didn't talk anything. Don't hide behind the screen. Please make some answers. If you have a question, bring it up, okay? All right, let's move on next one. I saw a lot of silence. Okay, let's see the number 9.
I'm here.
All right, finally.
I'm also here.
Okay, let's see number 9. Number 9, so we talked about this one right now, right? We right now give some example earlier we already talked about this part. So we can graphing easily for this part, right? So the axis of symmetry, this is quadratic. The axis of symmetry is x equals 0, right? What's the vertex? Vertex is 0, -7, right? 0, -7 is right here. So it's 0, -7. So when we graph in here, we think we need to find what's the x-intercept. What's y-intercept? X-intercept is equal what? 7/2 square root, positive and negative. So here is 3.5, close to 2, but not close, bigger than 1, closer to 2, right? So here is 7/2 square root. This negative 7/2 square root negative, all right? Maybe not so balanced here, so should be a little bit closer. So the mouth open is up, right? So you guys should be graphing this quickly. I didn't graph so good, but it's close, okay? So what's the domain of this part? So domain can be -infinity to +infinity. Domain is x range, right? X range can be here.
And then the y range is the range of.
So, yep. So y would, domain will be, I just say D, all right? So -infinity to
-7 to infinity, +infinity.
Yep, exactly. So -7 to +infinity. That's it. So easy, all right? Let's see this one. So this one is
Another parabola.
So yeah, this is parabola as well. So what about y-intercept? 0, 5.
0, 5.
What about
And
x-intercept?
the mouth opens downwards.
Yeah, square root here. So should be here is a little bit bigger than 2, right? Less than 3. So I suppose here. So here 1, 2, 3. So it's supposed in between 2 and 3. -2 and -3. This is positive and positive, should be somewhere close here. So when we're graphing here, like should be like close like this. All right. So what's the domain? Domain the same from the -infinity to +infinity.
The range is from +5 to negative.
So the range, yep.
Negative infinity.
Range should be -infinity to 5. Right, use the bracket, and this one use the parentheses, left parentheses. Range. All right, you got it? So it will be easy, right, for this part?
Yes.
Yeah, super easy for everyone here. Excuse me. So did you guys, here is a easy part. Do you guys have any question to this one?
Not me.
Great, great. I need to question someone as well. Austin, did you get the right answers? What way I show up here?
Yeah.
All right. Enoch. Did you fall asleep, Enoch?
Or he might have gone to the restroom.
Not yet. We just beginning classes less than 25 minutes. All right. Lila?
Yes.
Kongwei?
I got it right. I have no
Okay.
questions.
Okay, great, great. All right, let's move on next one. So, Enoch, I didn't get your answers. I suppose you fall asleep in the screen, all right? behind the screen. All right, let's see this one. So this is our new, I think you guys maybe already do this before. So we say when we earlier said about say y equal something like say x 2x squared minus 7, like this one. Right now we change the y into the like this. This is called when there was a function. Do you mean here is function? Function means only when you input 1x, generate only y is only one data, right? All right, generate only one data y. These kinds of thing we say function. So at these kinds of cases, we can change y. Use this one. Describe we call function notation. Of course, sometimes you can use describe like this, or sometimes use a different, all right, different description, and use many different kinds of description, and use sometimes you can see use the edge. So this is generated means the parenthesis inside here is input some data. After this transform, and output actually is y value. Just input x and generate this data. This data we use as the function value. So use these kinds of notation, replace y. When there was a function, we can replace, but if they are not function, we don't use it, all right? So this is basically say function notation, replace the y when there was function. Okay, so inside just the signal behind here, something like give you y, you don't know when, what's the x. So here you can know what's the input and then what's the output. So it means input output can describe in one thing. All right, so something like here. So when you say fx equal this one, you say when your input is x, output is 5x minus 3. So when you say find this data, so you can say input is -2, right? So just replace the x with -2 and do the rest calculations. So here you can get a -13, right? So here actually you just finds exactly just input the x and output the function result. Right? Same here. So g actually when you input is 1.5, so actually it's replaced with x with the 1.5. All right, time 1.5 minus 4. So here is 3. So here is 2.25, right? 3 times 2.25 minus here is -1. Here is 3 minus 4 is -1, right? So here is 6.75. So result is 5.75, right? 5.575. So you can get this one. The same. So this is just like a inside the formula. So most of the time, like hide this one in behind. So when you in near future you goes to the program class, you can coding these kinds of formula in behind. Let me give another example here. Let me share this one here. Let me open one here. So let me quickly open it here. Oh, sorry. Let me open one Excel. I don't know, do you guys use the Excel? Okay. All right. So let me share one Excel. All right. Did you see me Excel format here? Everyone? Hello, everyone. Did I disconnect you guys? No, I can hear some voice.
No.
Okay.
No.
All right. So suppose here is say input here is X. Output here is Y. Okay. So I say here input is 1.5. So Y, I define it. I define what? Define 3 times this number, all right? And actually square of them, right? So you need to time this number one more time. And minus 2 times this number again. And right now is plus 4, right? Is it plus 4? Actually, right now here is plus, right? Here is plus and minus 4. So you can see, when you put it 1.5, you got this data automatically out of there. So if you say, I want to input a 3, you just don't need to do that. You can automatically got 29. If you got 5, you can see the number is 81. You say -5. All right, so you got a number is, so here is just auto value is 0. If your output is -4, I input here, you get here. So you can put any number, whatever you like. So this is just like a program in the back. When you do the coding, you do the program, you will in the behind, they automatically do this calculation. So what's the behind here? You can see if you click here, you can see say 3 times this the number input square plus 2 times of this number minus 4. See? So if you graphing this number, all right, let me graphing here. So you can say insert you can see here. I need to take this out. And if I sequence these one numbers, if I sequence this, all right, I take this out. The number, just X, is a sequence number from the negative to the smallest to the biggest. So you can see, right? So if I put the right number here, I say -5 is right here. You can got this one, right? So you can insert, you can got, actually you can got it here, actually somewhat. If you smooth it, actually it's somewhat, will be got even better. Even get the more result is pretty parabola. If you put all the data together, this one will be parabola curves. All right. You got it? Everyone got it? Okay, so this is the program part in the behind. Program behind. All right, so let's see, go back to here. Go back to the PowerPoint. Did you go see my PowerPoint? You will see my switch back in my PowerPoint?
Yeah.
Yeah.
Yep, okay, so let's finish this one right now. So for this part, here's equal what? F half, right? So you just needed to half of length replace with the X. So here actually is -7/2, right? So here is -2/7, right? All right, so see the last one here. So see the last one here. So this one is means 3x replaced with a plus 3, right? -1. So you can got After distributing inside 3a plus 9. 3a plus 9 minus 1 here is plus 8. Right? So you can go here. All right. So this one would be super easy. Just like the input 1, you just replace it with the one input. You can get the results. Right? Okay, let's go next one. So this one would be more easier. We just more practice about this part. So here, fx, here is the -1 put here, so -7, right? -1 put here, the -4 minus 3, -7. What about G3? G is right here, right? So here actually you can rewrite it into x plus 1 square, right? Is it correct? So if you say gx equals 3, G3, so input 3, so here became 4 square, right? So equals 16. The answer is this one. So what about this part? So this part means 2 of them. So fx2, f2 plus g -2. So f2 equal 4 times 2 minus 3. Actually here equals 6, 5, right? Plus, here is -2 plus 1 square, right? So here is, I'm sorry, here it's wrong, it's not here. Here is the 5. 5 plus 1 equals 6, right? So the answer is here. So this part the same, 4 times half minus 3 equal -1, right? -1. What about this part? What about this part? So -1, g -1 and then square. So you need to do this inside calculate first. G -1 here is 0 actually, right? So equal 0. The answer is 0. The answer is 0. Is it good? Anyone have question here?
No.
All right. Let's move on. Let's move on. So we're talking about a function notation and evaluation right now, right? So like this one would be more easy for us, every one of us. So here, the answer is just replace x with the a, right? With 3c times 4 equal 12, right? 12 plus 1, right here. So here equal 4 times 3c, just replace x with 3c, right? So you can get these answers. Same here, x replaced with the f, -x. So x replace -x, right? Because of x, the initial x replaced with the -x, right? So here became -4x plus 1. So the answer is this one, right here. Okay. All right, so x replaced with a plus 3, right? A plus 3 plus 1. So here got a 4a plus 13 plus 12 plus 1, so equals 13. So the answer would be this one. All right. Okay, see this next. So x equal replace with the a plus h. A plus h. X replace a plus h. So equal 4a plus 4h plus 1. Right, so here is Lisa's answer. All right, so let's super easy, right? Got it? Anyone got it?
Yeah.
Yeah.
Just make sure x replaced by the part with this one. Especially like this example, maybe you guys maybe not very well understanding. This one. Just y, x replaced by -x. in near future, we will be talking about called reverse function, Just like so y equals 3x plus 1. What the reverse action is? So x replaced by y replaced by x. So here it became like this. This is called reverse function. In near future, you will be finding this so interesting. But you guys next year maybe goes to the Algebra 2. You will learn this part called reverse action. Here, just function just replace x with the one with the input, right? So it will be easy for us. Okay, let's go next slides. Sorry for some noise in behind because my kids running around. Sorry. Okay. So let's move on with this one as well. Became more complicated cases. So x actually right now replaced by 3b, right? So here became, so all x replaced by 3b, right? Make sure just only x replaced by 3b. And the rest format was not changing. 3b, here is 3b, sorry, I changed it to 2b. So here became what? 2 times 9b squared. Here became 9b plus 5, right? So here became 18b squared minus 9b plus 5. That's it. That's it. Right? Okay, see this example. All right, before I move that one, I need a question. Did you guys have a question to this one? Just replace the x with the one actually input. You guys have this question? Anyone? Please.
No. No.
No.
Enoch, did you wake up? Up to now, I didn't hear any voice from you. Enoch? No. Grace, did you fall asleep too?
No.
All right. Grace fall asleep.
What Grace?
Grace is right behind there.
Which one? Cassie.
Right here. He didn't put any picture and photo and video here. That's why nobody can see. See if he put a bird there. All right. Brian, could you please go? I will talk to you later. Okay, so Brian, can you please make noise a little bit slow? All right. Okay, all right. No questions, right, guys? So let's move on this one now. Okay. So H is H3A. So the input is 3A. So it means we need to replace the x with 3A. So here is half times 2, 3A, right? So here half actually we can write into like this, right? 3A. So we can combine them. Actually, the exponent part, right? Combine together. What? Grace not for sleep. Okay, good. Mm-hmm. Okay. All right. So let's see. Right. So actually in this part, if you want to do a little bit more details, here actually you can say this part, you can say half, right? And this part, Actually, can rewrite is A times like this. Is it correct? Right? But they are the same, right? They are the same. Here is the same. Here is the same. So depends on the calculation. This is the exponent part. Is part exponent. Is part exponent part. All right. Any questions before I move next? Mason? No, I don't know.
No question.
Okay. All right. So no questions. Let's move on this part. All right. The question here is, since the fx equals 3x squared plus 1, the question is, did this part make sense?
Yeah.
All right, let's see. So fx equal 3x squared plus 1. So we want to find out x plus h. So means the x part replace with 3x plus h, right? X replace 3x plus h, right? So this is that's what we got. So actually this one can be, if you use our earlier message, say this part x is changed into what? 2xh plus h squared, right? Plus 1. Is it correct? So here became x squared plus 6xh plus 3hx plus 1, right? So this is what we got for the left part, for this left part. What about right part? He say, the question asked here is, does this equal this make sense or not, right? So we see the right part. Right part, fx, we know fx. We know the fh. Fx is just 3x plus 1 itself. What about fh? So 3h squared, right, plus 1. Is this one equal here? Looks like no, right? So this piece, they equal together. This part, they equal together. This one, they equal together. But here, this one is not equal together. So it means they are not equal. So here is not equal, all right? So this one, in this case, is not equal this part, all right? It's not equal. They are not make sense. They are, if they want to make sense, they need to make sure this part equals 1, but not, they are not all time. All right, got it? Did you guys got it?
Yeah.
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 Yeah, great, great. Who didn't got it? If anyone have questions? No questions? Enoch, did you wake up? I don't know. Up to now, I didn't hear Enoch talking yet. Enoch, unmute yourself. Give me a hint that you are wake up. Bradley? Yeah. Listen.
Hello.
Ellison 1. Oh, Enoch, you are there? I don't know. All right, let's move on next one. Wait, not wait. We go some more interesting case, all right? So, when we talked about function, we earlier focused on linear graphing, we focus on quadratic parabola curves. So right now we move a little bit further. I know you guys, some of you guys already learned a lot about this part, but I thought I know someone mentioned, some parents mentioned this to me, saying they already learned this part. Why are you talking about all the time? I know, but most people didn't learn, right? So let's see this one. So when we say y equal x, this is what linear line. When we say y equal x squared, this is like parabola, right? But right now, if we changed into like this one actually will rewrite into x negative 1, right? This is called rational function. So obviously x cannot be 0 because x is the denominator part, right? X cannot equal 0. If they equal 0, it means the denominator became 0. You just like you have an apple, try to divide to give to nobody. So it's not make sense to ask question each person, how many each person got it, right? It's not make sense because you didn't separate the person. But this doesn't make sense. That's why when you say x cannot equal 0. But other than x not equal 0, what is possibly, right? Like right now we say at y equal x, the domain is negative infinity to positive infinity. And range is negative infinity to positive infinity. Right now, in this case, right now domain is changed. Right now domain is negative infinity to 0, right? Because x 0. Because x was not cannot equal 0. So the domain would become here. All right. So let's graph what it looks like. Actually, I put something here in the right corner, right bottom corner. Let's zoom in here. Okay. So actually, you can find some more information on this website. Well, let's graph them together a little bit. All right, so x cannot equal 0, right? X cannot equal 0. So if you do graphing, you can use the table methods as well. Right? You can still use these table methods. When x equal 1, y equal 1, right? So here it's got a 1, 1 is right here. When your x equals 0.1, actually y equal 10, right? So more closer here, more bigger, more close to, if you 0.5 here equal 2, right? So right here, this one. So if you x equal 0, 1, it's more bigger. So that's why it's became more bigger and bigger, bigger, really close to the 0. Here, this one is 0, right? The same. When you got negative part, when you say negative 1, y equal negative 1. When y equal negative half, x equal negative half, y equal negative 2. So more closer, that would go this part. Right? So link all the kinds of points together. So became this green, here's blue line, all right? So you can see what's the range of this one. So it's negative infinity, right? is close to 0, but never equal 0. Right? And 0, this is upper close 0 to the positive infinity. So the range would be negative infinity to 0, and should be saying n means this one. All right, in near future, I talked about this one. This one means n, this one means overlap, okay? This means n. This means overlap, the common part, overlap. Let's talk this a little bit later. I just give you a hint here, it's n, all right? N. We'll talk this a little bit later. This one we will talk a little bit more. When you go to the high school, oh, sorry. Right, so this is graphing. So this one we totally, you can see this one is what? They like a butterfly, right? 2 butterfly wings. And they are balanced. They're balanced by this side, like flip over. You can, the symmetric line is right here. You see the symmetric line is right here. Another symmetric line is right here. This one y equal x, is y equal negative x. They have 2 symmetric lines. When you flip over through the symmetric line, they will overlap, right? So left, right, flip over, you overlap. And this part, this based on this symmetric line, the left and right flip over, they will be match up as well. So this one is like this. This one is like this. A rational, this is the most simplified rational function. Most simplified. So you can see when the curves, these kinds of curves is not linear anymore. They are not looks like when we do the quadratics, it looks like this, right? Looks like let's switch some angle to here, but still not so close, right? Because because you can see the actually these data never touch this line. They have very close to this 0, but never equal 0. And the same, this one close to the positive infinity, but they never have a cross to this y axis. The same here. They are very close, but never have any intercept. It's very close, never have any intersect. Even they are go to negative infinity, here negative infinity. They never intercept. They just very close, almost touch, but never intercept to each other. So that's the one. Let's see next. So that's special, right? It's a special. Did you guys heard graphing these kinds of curve before? In somewhere? Someone have learned this part already? Mason, did you learn this one before somewhere?
Yes.
You learned this already? In your school? All right.
I self-study.
Self-studied already? All right. Let's see something more interesting one here. Okay. Did you self learning this part? All right. So let's see this one. Okay. So this is called rational function. Right now we say, sorry. So this is called rational function. Actually, this one, before we do this question, we should learn like this one. All right, let's see this one. So this one actually is like this. Right now we say rational expression. Say x equal -1, right? This is the negative number, and this is the fraction number. What are we earlier learning? This is a linear number. This is parabola, right? We go to the 1, 2, and we go to the fraction, and then we go to the negative number. In near future, you maybe will learn something like I, imagination number, but we not learn this time. Don't give you too much complex, all right? This one will change, will be fine, right? This is linear number. This is a quadratic number. And this is the rational exponent, rational function. And we learn something like a fraction number here. We go to a simplify. We didn't go to these kinds of fraction, all right? We just go to this, a very basic one first. So y square root x. Let's see what this looks like. So most of the time you can also use the use the function notation will be right like this. If we do like this, how we graphing? All right, we're saying graphing like this. Still use the table. But since this one is under the square root, we use the real number, all right? I know we learn if x is a negative number, square root will become imaginary number, right? So we don't do left far, but you don't go left far. We just still go to the real number, right? So x need to be greater or equal than 0, right? At least. So it means they are domain. They are domain. Domain means what possibly x can take. So it means there is including 0 to the positive infinity, right? What about range? We'll talk about range a little bit after the graphing, okay? So this one at least give me a hint. Say x is a positive or 0, greater or equal 0, right? So x, y, we use the table methods. So if they 0, y equals 0, right? Square root 0 equals 0. If we 1 and also 1. What about 2? Square root 2. What about 4? Here became 2, right? About 9, here only got 3, right? So when you're graphing here, you only need to graphing the bigger than 0 part, right? So 0 is 0, and 1 is right here. Well, like 2, square root 2 actually a little bit higher than 1, right? Well, like 3 should be go very far. It's for about 9, maybe somewhere here is 3, right? So it means when you're graphing is like this. Like this. All right. So here 1, 2, 2 is here. Here is 1, 2, 2. This is 4. 4 here is 2. Here is 9. Should be far away about here. It got 3. So it should be look like this. Okay. Here is the 4 and 2. Here is 9 and 3. So here is 0 and 0. There's 1 and 1. So the graphing is pretty roughly. Pretty roughly from here up to now. So it should be like this. Although this one will be growing, like if you continue going on, this number, yes, is will be positive infinity. But the minimum value is 0, right? Minimum value is 0. And so we can see the range. And the range will be 0 to positive infinity. So pretty broad, So the domain is from the also positive number. Range also need positive and 0 number as well. So this graphing. So let me show you the one I take from the book here. So let's graph in this one. I'm sorry, let's take a picture here. So let's graph in this one. They are very similar. They are very x plus 2 actually very similar. Looks like need to move x to the left unit, Yeah, you see here, a little bit blurry, not so clear here. So actually this one is exactly the same what we graphing right now. Move all curves to the left 2 unit. Right now what we graph when we graphing the y equals square root x, actually it's right here, right? One is right here, 4 is goes 2, and then goes 9 is 3, it's right here. It's like this. So this is one here. So for this one is right here. So move the curves to the left 2 unit. So you can got it here, right? Because you can also graphing use the table x and y, right? So this part underneath part should be greater or equal to 0. So means x greater or equal -2. So means the domain will be -2 to positive infinity. But what about y? Y is only above here, right? Y above here, above the 0. Here's y equals 0. So 0, so range still the same, didn't change. It's 0 to positive infinity. 0 to positive infinity, right? A little bit different. But you can graph it from this way, say x equal -2, y equals 0. When x equal -1, here became 1, right? Here became a positive 2, and here equals 2, right? 2 plus 2 equals 4. Square root will be 4, right? So here because 7 plus 9 square root will be 3. Just like that's what we graph. Actually, the blue line graphing here. Yep. So you can see graphing based on the at least 3 or 4 dots. 1, 2, and positive 2 is like a 2, and positive 7 you got a 3. Yeah, so you can graph in here. So you can graph in this way. So I know this is extensive part about the graphing. So let's hopefully, I don't think it's a big change. The thing most important, you need to figure out what's the domain, what possibly range. If you can graph in this part, you can find out. So someone asked me, say, x right now we learned already. When x equal -3, their square root is negative. It became I. Can we graph in this one? Yes, actually this one would have became earlier what we learned, imaginary graphing, right? Last couple of weeks we learned complex number. This is imaginary and this is the real. And in this whole plate, what are we on graphing? Or actually in the real plate. So it looks like we need the extensive part. The real part will become extensive x and y. So this one will be changed into 3D graphing. We don't go left one. I don't like make it too confusing of your part. Someone will teach you later in when you go to the college. We didn't go left one, okay? So we just focus this part. All right, let's move on next one. So, do you know how to graph in this one? Oh, hey. Just like, hey, why you guys always ask us graphing something so challenging one? No, actually we are not. We just try to let you know what's going on here, okay? So here actually, like these kinds of cases, normally we don't graph in that one. I just give you a hint at something like when you met these cases. So that thing, like bottom part, you can change into one, like this, x squared. So when you do this rational graphing, So it means x cannot equal 3, and also x cannot equal -2, right? Right, that's more important. So when you do the domain, this domain level of limited, so it means you cannot go this 2 point. So, all right, let's see what the picture looks like. I know you guys maybe say, "Woo!" The domain here. So domain here. Let's see. So here is -infinity to -2 and -2 to +3 and 3 to +infinity. So have the 3 different area. So when the graphing will be like this. So you can see this one, actually 3 here. X equal 3 is right here. X equal will be right here. X equal -2 will be right here. So this is some of the deformation of the rational expression. So x cannot equal -2. X cannot equal negative and +3. Is 2, 7. All right. So what about the range? What about the range? So this one definitely cannot equal 0, right? Can they possibly equal 0? Yeah, not, right? I actually, when x equals 0, yeah, they can be equal 0. That's wrong, I'm sorry. They can possibly equal 0. I think they should be somewhat across 0 here. So if they, something like x equals 0, the result is 0, right? Or 0, 0. Yes, they are 0, 0. They cross here. You can see the cross 0, 0. They do including 0, 0. Right? What some other part was missing here? I don't know what this part was missing. So this one will be, keep a question for yourself. What possibly they didn't get it? What possibly they didn't get it? Which part? So x cannot equal 3. X equals 3, this one became 0, here became 9, right? X cannot equal -2. -2 here and -2 over 0. So let's definitely have somewhere was not touching. So I keep a question here for next week, all right? Let you guys say, find out what's the range of this, which part. Maybe a little bit challenging. Just keep thinking, brainstorm yourself. All right, that's all for this week. So if you have any questions, and we will talk more next week. And let your parents send message to me.
Thank you.
Thank you.
Right. See you next week.
Thank you, Dr. Lin. Bye.
No problem. See you next week.
Thank you.
No problem. See you next week.